teacher is an energy nexus engineer and multidisciplinary researcher at National Renewable Energy Lab. So he got his PhD from University of Colorado in Denver in interdisciplinary sustainable urban infrastructure program. For those of you who are NSF fellows, NSF Power Fellows, he was a Power Fellow. In that program, he was also an NSF Hybrid Fellow, so he's been through some of these NSF programs. And if you're interested, I actually really encourage you to talk to him about that as well. So he got his PhD, and he had a Fulbright scholarship before joining NREL. So at NREL, he co-leads Urban Nexus Science and AMP Innovation and Smart Cities Energy Nexus. Among other activities that he does at NREL, he also co-leads DOE and New York State Energy R&D Smart Cities work, which is a collaboration partnership between cities but also universities. And he supports various urban behavioral and decision science and area carrier monitoring at NREL as well. So thank you for coming. It's really exciting because we don't necessarily always talk to engineers that are not material scientists. So thank you, and we look forward to learning from you.
That's great. Thank you so much. Can everyone hear me okay? Okay. It's an honor and a privilege to be here. I'll say this is my first keynote, and I'll say it's a wonderful opportunity to be here at UPenn with a really bright and exciting group of folks, just in talking with the students at lunch to some of the research faculty. I think for NREL, it's always the role of how do we best support the next generation of R&D, create new talent pipelines, and solve real-world problems. And so I'll give you a 2-slide preview, and then I have a longer set of slides, but I'm happy to make it interactive, and I have an exercise too to get you talking to the person next to you and thinking towards not just looking back at what we discussed today, but looking forward how we can all work together. And so I'll start with, I've been at the National Lab for about 5 years, and I want to thank both just Russ and Kristen for inviting me here. I think the NSF Pyre connection was actually the project I was really full-time on as a postdoc just before I joined NREL. And it was a Pyre across the universities, included University of Colorado, Denver, where I wrote it from with my PhD advisor, who came out of the Carnegie Mellon engineering and public policy background. And we had an IGERT on sustainable urban infrastructure of about 25 PhD students across engineering, architecture and planning, public affairs, public policy, the Department of Health and Behavioral Sciences, and the Department of Geography and Environmental Sciences. And so a very interdisciplinary approach to a research program. We would have weekly seminars, bring in external folks, learn, are we speaking the same language, or are there different, even just the word structure, what does that mean to an engineer versus someone who's in behavioral sciences, to a model. So a lot of just, even without even getting across cultures of different nations, just between different disciplines, how do we work together more effectively? So I'll say the Pyre included University of Colorado, Denver. For us, it was Yale, Georgia Tech, and University of Minnesota. And we had 3 different partner institutions in India and 3-4 more in China. And I actually had a unique role in that I spent a year of my Fulbright during my PhD wrapping up and getting to introduce all the Pyre students to different types of problems, field work, types of research questions that was of interest to the city, to the utility. And we did that in 2014, and then we spent a whole summer in China, 2015, across these different institutions of US students with Indian students, US with Chinese, about equal amount of 8 to 12 PhD students on each side. And then the final year was a culmination at the National Academies of Engineering, with everyone participating for about a week. And so really, I would say it was one of my favorite parts of NSF's award programs, the Pyre. And we had a complimentary USAID peer, which was funding the partners in India to work with not equal amount of funding, but funding on their side, called Partnerships for Enhanced Engagement in Research. The Chinese could not receive funding from the US AID. They were not considered a developing country setting, but it was clear that they also wanted to bring resources to this. And I'll say that that project really shaped my trajectory. So I'll give you a little background on this two kind of slide image or graphic was produced with our communications team to how I communicate my work and the work of our institution around urban. X is a variable. X can be many things. It could be sustainability, it could be resilience, it could be energy, it could be water, and infrastructure. And I think we're really just knowing that this is becoming an increasingly urban planet. We moved from 1907, 1.7 billion people on this planet to now over 7 billion. Half of those people live in cities. We're going to be adding populations to urban areas over the next 20, 30 years at a pretty much unprecedented rate in human history, and that creates a lot of new demands and opportunities as well. And so when I talk about Urban X and now Urban Nexus Science as a new form of science where we're aiming to co-create, co-design with different stakeholders, we're really working in that information environment. And so the 5 ways we say we can engage is connect with communities and the public and different types of stakeholders, startups, utilities, public transit agencies, regional governments, state governments. We're working towards integrating data. Rather than big data, I much prefer high quality data that helps someone somewhere answer a question that they're trying to address. And we often play a role of inspiring new thought or action leadership from what we've learned across the nation or across the globe. And when things are implemented, whether it's a pilot, a program, a policy, we're involved in that process of co-designing change objectively without a profit motive, which I think allows us to play a unique role. And then we're measuring and sort of validating how effective was this, or how effective were these different strategies, how do we prioritize going forward. Internally, we had a vision we called Humans in the Loop, a new capability that's really, I'll admit, I didn't know how to speak to the material scientist crowd until I had the 3 previous speakers bring the city perspective. That's more my realm of comfort, but not just the nanoscale, but the human scale is perhaps where I spend most of my time. When we're thinking of new emerging technology, I would describe it in 3 ways. Emerging technologies, new information, how is that impacting people's behaviors or decision environments? Number 2, how do we bring people into our research and into our realm of questions and data-driven discovery that makes us more aware of the real-world problems or different audiences that could find our insights with analysis, modeling, data integration, visualization much more useful or usable. And then the 3rd, I would say, is rather than 2050, which we heard 80%, or 2080, which NREL has scenario models running across the globe and across the country, I'm much more focused on how do we improve people's lives today. And so the premise was, or the hypothesis, and this was through an internal investment called Laboratory Directed Research and Development, which funded my initial first 6 months at the lab to create a runway for my research portfolio. Can we save people time? Can we save people money? Can we add comfort or convenience to their lives? Can we enable new opportunities for safety, new job opportunities, and address things that people value or they prioritize? And then the co-benefit of that human-centered focus is, does this bring additional energy benefits or greenhouse gas emission benefits or help reduce certain risks that is more at a societal or systems level? And then just externally, the mission statement is towards energy systems, infrastructure services for sustainable, healthy and resilient cities. Smart cities came up after the first 6 months I was there in a big way. But I would say we had a core team of 3, 4 of us, different interdisciplinary backgrounds. I was attracted because of that human behavior focus. We had someone with a behavioral economics and aerospace engineering PhD, someone in computational, like neuroscience and biology, that took in a whole different area, just very good in computer science as well. Someone from Stanford in civil engineering and GIS, and then myself with that interdisciplinary engineering, planning, policy, behavior change background. And so we'd have a core team, we'd extend it out to different people at the lab. Every Friday we'd have a whiteboard session, come up with new concepts, new ideas that we thought could be not incremental but transformative in terms of study designs, and get different people around the lab giving us input, feedback, and sometimes external visitors as well. And then it began to be interfacing and learning from cities, designers, regional partners or planning agencies, those that are operating infrastructure, university partners to co-create research, international networks, industry, and so on. So I defined our approach as we're interdisciplinary, we're human-centered, and we're systems-oriented. We often are in this research space of objective, credible data tools. Let's show what happened there. Sometimes training in terms of new decision support tools at the science policy interface or science real-world decision-making interface, and then trying to optimize for those human-centered goals and in ways that also improve or transform our energy systems and services. And then just as a look at this process, and I'm happy to take questions at the end here, we called it Urban Nexus Science Towards Innovation. And it's across systems, scales, and contexts, starting with people. How do we improve their lives, young to old, gender, income, different factors geographically, whether you're in the middle of the country in the Midwest or you're out in the big city in New York. And we would say energy is really our lens because we're funded primarily by the Department of Energy. And so we looked at this grid modernization report of a 300 million, all 17 labs involved in how do we transform our grid in the 21st century. And they defined 8 characteristics that they aspire to. I said, let's pick 3 with cities that they care about. Is it more affordable energy services, more reliable, more adaptable, more flexible? And you could probably say the same for a water system or a transportation system. But the way I would try to connect it back to people as our driving force here, I would say energy is almost this backbone of everything we rely on a daily basis. I'll say if our power were to go out for the next 8 to 12 hours, our ability to treat water and wastewater for clean drinking water or wastewater management, to storing, refrigerating, distributing food, to moving people and goods, to having comfort in our buildings, to manufacturing or industrial production, to communicating, to manage waste. Every single one of those services would be impacted. And the other way you could think about it, we're the National Renewable Energy Lab. What if we tried to power 100% of those services or a prioritized version of the critical infrastructure services with 100% renewable electricity? And what would that do after a Hurricane Sandy, a Katrina, a Puerto Rico Maria disaster, or for a forward operating base for the Department of Defense or other environments? And so I'll usually say similar to our first speaker, there's many terms for sustainability, many terms for smart cities. Rather than picking a definition, it's more how do we measure it in the context of the local stakeholders that care or are setting priorities or defining problems, and how do we go about measuring progress along those lines. And so that could be very environmentally focused, land, air, water. It could be much more economic focused, or it could even just be social equity or justice focused as the 3 legs of sustainability: economy, environment, equity. And equity, we had a whole research coordination network on sustainable cities and the energy, water, climate nexus, and the early career group. This was 20 US universities with their nearby cities and European networks, Australian networks doing similar work. The early career team had budgets for 2 workshops. Our first one, we just focused on that equity dimension, which we said it's not getting enough attention. Economy usually drives this, environment secondary, and then the third leg, that's the wobbly leg of this stool, is the equity part. And so I actually chose to work with a sociologist for my postdoc and found her really engaging. She's from Mexico City, public policy background, and we actually brought her from NCAR over to NREL just this past year when NCAR's budgets were getting hit in the change in the administration. NCAR, NOAA, NIST are all in Boulder, a beautiful location similar to Grenoble, but I would say this was the hub in the world for the most IPCC climate scientists per capita. And so for people like Patty, she was always trying to translate this global challenge space to very local. How do we make decisions with this new information, these changing projections, and based on understanding of risk and vulnerability that already exists in our communities, whether that's extreme heat, it's pollution, it's flooding, and so on. So I'll say we define 3 types of equity that I think is relevant to this type of group and maybe engaging with the city of Philadelphia in the future: distributive, procedural, and intergenerational. And there's probably many others, but distributive being we're always going to make decisions where there's some benefits to some populations and less benefits to others. There may be even more burdens or unintended consequences. There's also procedural. Who gets to participate in these processes that shape our actions, our strategies, and are the people that will be impacted by these decisions getting to equally participate in the process? And is it token input, or do they actually have the power and the financial means to influence the decision process? And then the third is, I'm a civil engineer by initial training. Our infrastructure, most of it's been built over a course of a long period of time. It's very hard to change what's already in place. It's much easier to get it right the first time, was sort of the message with India and China, that they could perhaps leapfrog over Western development models, with these 3 countries being half the world's energy use and greenhouse gas emissions, and a quarter of the world's population, and both of those indicators rising in terms of proportion over time. What I'll say is that we thought of intergenerational as, from an indigenous perspective, the decisions made today impact 7 generations from now. How much do we consider that in the terms of the decisions we're making? It's very hard to change the Public Utility Commission regulatory structure based on rules and norms that were based on a very different set of parameters or concerns back when it was first formed. And so changing these types of environments can be an intergenerational challenge and level of questioning. And so I'll stop in the sense of sharing this graphic. I think the only 2 things I want to mention is technology and governance became the big piece of the smart city space. Emerging technologies, new ways of governing with data or citizen input or crowdsourcing. But when we work with these different systems in terms of collecting data on the left, we often try to shape our inputs in a way that could inform an individual. It could inform the design of a product, a household, an individual building or single infrastructure, up to multi-infrastructure across sector, intelligent campus, which NREL has as a net zero energy campus, to district scale innovation, the whole citywide. And cities acting as aggregate actions, how does that influence global, say, mitigation or global sustainability goals? And then the last part I just say in walking through this sometimes is we're here to, not as researchers, we can come up with millions of questions that fascinate us and might be interesting to us as individuals, but we always want to connect it to the real world decisions that are happening. And so my background, or our PIRE, was focused on developing low carbon, healthy, resilient cities. You could replace low carbon with smart or competitive or livable. What questions come to mind when you're a city manager making daily decisions about improving the services for your citizens, to maybe an emergency manager, to health being defined broadly, not just in terms of individual health, but health of our, my wife calls it one health. She's a veterinarian, so the health of our ecosystems, our animals, our humans. It could be the health of our economy. And I think my PhD was actually a different type of nexus. It was looking at infrastructure, environment, and health in rapidly growing cities, and that's what, through our IGERT, we had 2 trips there. On my first trip, I said, this is a really exciting place to address big problems. I applied for a Fulbright and a PIRE to fund after my 2.5, 3 years of funding, and we were awarded both, which was a nice synergy. And I'll move into the slides, but I'm happy to just try to answer any questions that come to mind and just looking at this process, or fill in example types of projects if folks are curious. I'll let you digest, and I'll pull up the broader slide deck. And I guess I'll just say one last thing. The realization was DOE has always funded in silos. As much as they wanted me to help create a cross-cutting urban research portfolio, I said, I'm going to be in meetings all day long, going from the buildings team to the transportation team to the electric power grid team to our energy, water, and exit team, and I don't have time. I'm not going to get anything done. So I started convening my own, but I would say, let's just take 2 different types of sectors and think about, rather than these operating in silos, if we integrated them, what would be the new types of efficiencies gained, ability to reduce risk, or cross-sector learning that might be possible. And everything that's heading in a wrong direction, of whether it's pollution or poverty or any rising inequality, climate change, we always had an approach of, it's not just an engineer that's going to solve this. We need people that understand technology, that understand planning, policy, behavior change, and we have to figure out how to pay for this, so finance as well. And there's probably others I'm missing. Artists probably could be included in how we communicate more effectively these pathways. Okay, so I've grouped together different slides here from a few different talks. The most recent was last week, and that's the top left. This is the first US consortia proposal I've led. That was for $20 million from the Bird Foundation. We'll hear back next month. But it was bringing together two countries, the US and Israel, to learn from each other on energy and water. And so some of the slides are on that topic. I'll say for the US-centric view, you could think about language of security, energy, water security, to economic competitiveness. When I traveled to France most recently, that's the language I have to use these days. But there's also the questions of, for State Department, who we support, geopolitical instability when people lack basic services, or just human development, new choices, new opportunities for life pathways. The one quote I want to leave you with and make sure is the kind of key take home. I think it's a skill that should be in all curriculum across every department, and it's the acquisition of empathy. And it was a quote from Fulbright, but I think I really began to appreciate this over the course of the year. It's defined as the ability to see the world as others see it, allow for the possibility or humility that others see something we have failed to see, or may see it more accurately. And I think as we approach global challenges or just learning across different disciplines, that level of humility or ability to put ourselves in others' shoes, I think will make us much more efficient and effective in everything we're working on. Okay, so where we're situated, I live in Boulder. I work just outside Denver and Golden, between Denver and Golden. It's a beautiful location. We're one of 17 national labs, the primary for energy efficiency, renewables, and some of these different topics, energy, water nexus, smart mobility, urban science. We're probably two labs that don't have any nuclear legacy. Many of these labs are pretty far from cities or human settlement. And the overhead rates are quite high just with the nuclear legacy and types of expensive equipment. But I would say we work pretty closely with Lawrence Berkeley Lab and several of these other labs, and we're often asked, I think the biggest change from what I saw on the NSF side is just the fierce competition when you're putting together an NSF proposal and thinking you have a 1 in 6, 1 in 12 chance, even if you're really excited about it and you feel like this is going to win. To DOE, when I first joined, said, we have the money, we want you to work with your 4 other labs and come up with a good plan for how you would use the money and the different milestones you'd set. And it was a lot more hands-on, but to me, after pursuing all these NSF proposals with NCAR, where we could only get 2 months of our time covered as full-time researchers, I'd have to write, 20 different proposals to be successful, and usually we have to be supporting universities we couldn't lead on NSF proposals. I found DOE to be, this is great. We're being told we're getting the money, we have to write the proposal, but we know we're being awarded at the end of the day. And there's trade-offs. I think I can explain the NSF versus DOE landscape, and I think there's actually a nice synergy in working across these spaces. I'm not going to dwell on this anymore, but I like to look back, reflect. Being outside my comfort zone in different international contexts allows me to say, what's most important to do next? Or I have a 1-year-old son now. I don't have nearly as much time as I used to, so how do I zoom into what's most important for my time going forward? And I think that reflection is always important for each of us. I'll bring up here a key question that drives my research. I ask why, how, and how fast will some of these emerging technologies, infrastructures, new behaviors transition, leapfrog. An example I give is from landlines to smartphones in India or Bangladesh. Can we see other forms of leapfrogs or be creative in how we define those as from fossil fuel infrastructure to renewable energy, from private vehicle ownership to shared electric mobility, from siloed sectors to much more integrated forms of funding and planning. And I'll share one effort as a global assessment report I helped to lead, and we're now doing a book around. And then a key role I play at the lab is really mentoring earlier career scientists, several postdocs. Sometimes we host summer interns doing their PhD, and I enjoy that. I think it's a really fun, creative, how do we best support people pursue their passions and interests and in ways that can have impact and help them navigate a new space or the literature and just all the great people that are at the National Lab. Urbanization, there was a report to the president a few years back called Technology and the Future of Cities. I think it aligns with what we heard about just a significant amount of investment in the R&D and implementation space here. Some have described this utopian future with technology. Others have described this could actually be a nightmare, an example of automated vehicles actually leading to a 200-300% increase in energy use rather than a 60-80% decrease depending on how we utilize or how our behaviors respond to technologies of this nature. So many good questions. In terms of a global effort with researchers that are part of this urban research network led out of Columbia, we led a chapter on the urban energy space, both on the mitigation and adaptation side. This was the second global assessment report, and now the IPCC is thinking about having a dedicated urban report and urban chapter in all future efforts. There was over 100 different case studies and a really exciting type of global collaboration. I won't go into too much detail other than here's an example of, this is where all our power plants are located around the world. And so if you think about a storm surge or sea level rise, we have a pretty significant impact to our energy infrastructure. As well as what happens with temperature. Being in India, it's very clear to me that there's going to be challenges, and people will be happy to pay to go into an air-conditioned public space, shopping mall or so on, and we're already seeing business models evolve in this way. We're looking at the future of our urban energy system now as an integrated project with a public policy professor from the Biden School in Delaware of Public Policy, Andreas Arzinski, who's at the Brookings Institute, another colleague, Peter Marco Tullio, who's at Hunter College and Columbia University, leads their Sustainable Cities program, and he's a geographer. And we led the chapter, and we were now invited to write a book for World Scientific based out of Singapore. And we're moving along, but would welcome collaboration from some of this group if they wanted to take on a box, a case study, a chapter, or a context like France or South Korea as a comparative case study. Our integrated research in the context of energy-water nexus, I'll go back to that BIRD 20 million proposal in a sec, but we've defined 5 capability areas. It was also an internal investment of how can we be a global leader at the energy-water nexus. I think the most important is this decision science. That's the area I'm kind of leading up, and others are leading modeling, others on water and electric power grid infrastructure. How do we advance water treatment? We were just awarded a 100 million energy water desalination hub from the Department of Energy Advanced Manufacturing Office. That's between Oak Ridge, NREL, and Lawrence Berkeley with several university partners. It's on the premise that a country like Israel in the past 5 to 10 years moved to 80% of their drinking water from desalination. Others considering this, but it's still incredibly cost and energy intensive. And so the goal is to determine if we paired renewable energy with desalination and advanced treatment methods, could we bring down the costs in an order of magnitude way. The other type of research that's energy water is just water constraints to our power, electric power. You see a lot of examples here of cuts or impacts as a relate of lack of cooling water, high intake water temperatures or discharge temperatures that won't pass legal or regulatory compliance. You could think about cities and this nexus, many different solution spaces, from the planning side to water efficient energy production to a wastewater utility being a producer of energy rather than consumer, which we actually said for the Israel proposal, complementing the 100 million award, we've learned from Israelis in terms of drip irrigation, desalination, but we think before we even get to desalination as a technology, they've also moved to 80% of their wastewater being reused for different purposes, whether that's agriculture, industrial, municipal use, and that's actually probably a third of the cost. And similar to that's linear take, make, waste, moving to a circular model. We treat everything today to the exact same standard, whether it goes in our dishwasher, our washing machine, on the front lawn, watering the golf courses, to drinking water standard. Could we instead treat to the purpose and reuse and treat the reuse of water to the purpose, whether that's for agriculture or other uses? So that's the premise we're looking at. In the context of urbanization, a challenge that actually brought me to Ecuador 3-4 years ago is the World Urban Forum, and it's held every 20 years. The first one was in Vancouver, then in Istanbul, and then in 2016 in Quito. A really amazing global conference with national delegation. I was part of the US government delegation of HUD and USAID, State Department, DOE, and we were invited to pitch one of our top 2 competition concepts was a prize challenge we call the Urban Prosperity Prize for Renew Zones. And now we're actually moving from a prize, the person who led from the State Department, she was actually under Hillary Clinton and created the US Global Water Partnership, which is worth looking up as a 1 billion network globally of diplomacy around water. She said, let's build in an energy, a water, a food, and other components, and really focus on urbanization. I give the example of Delhi, India, where I did a year of my research. They're adding a whole New York City population over the next 15 to 20 years. No engineer has any chance of keeping up and building out the infrastructure fast enough. You have a lot of unplanned settlements. Land is always cheapest at the outskirts of cities, so you see informal settlements and lack of basic services, whether that's electricity, sanitation, nutritious food, and so on. And so our idea, similar to what I asked the question of our City of City of Philly colleague, is can we think of different districts or neighborhoods? It could be at the outskirts of Philly, it could be at the outskirts of Delhi, Cape Town, but bring together 100% renewable energy, improvements to nutrition, environment, water, waste, and make it a circular economy model. And address that specific challenge of, we know slums and informal settlements will double in population over the next 10 years. That's pretty wild, right? Whole cities that may pop up from scratch that don't even exist today. And I'll say Dhaka is a very good example where I spent a little bit of time. In the transportation space, this was one of my first sort of spin-outs of our internal investment. We received funding with the 5 other labs. We led the urban science. $50 million was awarded to Columbus, Ohio. My colleague Stan would go every 2 weeks, then once a month, and then once every 2 months over the 3-year period. It's now just closing up. And I worked with the other 6 finalists, Austin, Denver, San Francisco, Portland, Kansas City, and Pittsburgh. And with Pittsburgh, our kickoff workshop actually led to 2 different Carnegie Mellon 1 million projects where we're now supporting them both across Philly and Pittsburgh, which I think we want to bring UPenn into the fold, knowing that UPenn probably knows the space of Philly much better. And then also a rural to urban context of how do technologies get adopted, increase affordability in rural counties. And they awarded 5 different projects as DOE just this past year to 5 of the smart city locations to work together with a more rural location on what is the context in which these same technologies could be adopted in more rural or suburban areas. Many interesting findings. This is from, sorry, I have a thank you question. You can always email me here. Happy to follow up, but I'll say one just example of the implications for infrastructure of changing technologies today. Uber and Lyft was described in San Francisco as they moved from 3,000 taxis to over 60,000 registered Uber and Lyft drivers in a 3-year period. And if you thought about an Uber pool or Lyft line during the commute hour, it was as cheap as $3 to get door to door, whereas by transit it's maybe $2.75. You might have a transfer, you might have to wait in the rain or it's cold weather. And so just the decision structure for individuals in San Francisco is changing so quickly, especially for the higher income, that we just tracked airports where we had the first observability, and Uber Lyft wasn't sharing data. My colleague Alejandro, he's from Colombia, we were talking over lunch, but he was fascinated by taxis in Bogota and Cali. And for his dissertation, he became an Uber Lyft driver to collect anthropological data and engineering data of origin, destination, what was the mode that was being replaced. And I said, he came on as a postdoc with us. I said, I don't think you want to keep being in the field as a driver. There's probably other ways to collect this data. And we looked at public records requests. Airports started charging pickup drop-off fees to Uber and Lyft. And we just, through public records, said, how much money are you making per month? And could you show us your revenue records for car rentals and parking as well? And we learned, it was actually the most exciting data set I felt like I got my hands on, because we learned, wow, San Francisco's making $3 million more per month as a city. Denver, $600,000 per month. And at the same time, this wasn't coming anywhere close to what they were losing in parking revenues and car rental revenues. And so we said, wow, there's a really interesting transition happening here, a pain point. If we project these numbers out, in 15 years, 14 years, we would see half the amount of parking demand at airports. And what does this mean for our cities, where in Wyoming, for every vehicle, we have 10 surface parking spaces. In other places, it's 3 or 4, but I would say 30% of our land use in urban areas is just for a parked car that sits 95% of the time. And what if we could convert this over to more affordable housing, walkable areas, new types of retail, commercial, and so on. And so that's just one example of an interesting finding that led into a new $6.2 million project for DOE and Dallas-Fort Worth Airport, willing to pay $1.25 million to have us work with data to try to address what they plan for in terms of more shared electric mobility, resilience of the airport, a doubling of air travel in the next 20 years, which also has emissions implications. And we have a network of 6 or 8 airports that kind of built on the approach we took with the 6, 7 cities. So it's fun. I'm having a fun time here. We're getting money. We're growing our team. NREL across the board is, while we were afraid of losing 70% of our budgets when there was the change in the administration, the White House put out a proposal. It actually led to a lot of diversification strategy from our leadership. I was even sent to a Department of Defense Technology Summit in Tampa, Florida, where I walked into the expo hall and I saw drones with machine guns to robotic legs that help you run 3 times as fast and carry 200, 300 pounds on your back. And I said, oh man, how am I going to engage as our National Renewable Energy Lab in this new environment, this new space? I met with the Army Research Lab out of Fort Detrick, and he came to look at my poster on what we were doing in smart cities and transportation. And he said, we're working on access to healthcare and improved soldier care in terms of using automated vehicles, getting them out of harm's way, on-site renewable energy for refrigerating medicines. And so it's just an example of, okay, I think our ability to be nimble, adaptable, flexible is important. I didn't actually end up going this direction in terms of my research, and our funding actually, Congress pushed back. It not only sustained at the same levels, it grew. And while we were diversifying and seeing new funds from the state level in New York and California, Colorado, we realized we have to partner with universities in a big way, because we don't have the labor, the time to actually do all this work that's now coming in. And so I kind of moved in that direction. I've always liked working with universities and students. We have a colleague now, Ellen, who's full-time just in that role of building university partnerships. The types of areas we focus on, I'm happy to pass on these slides. Why we're unique as a national lab, we don't, we sort of invest in that space of what's going to be commercializable in a 3 to 10 year time frame, not what the private sector could invest in today. And it allows us to take more early stage, high risk approaches, and we can conduct research for industry in a way that we're not driven by profits or saying, city A, you should work with this private company. It's more, here's 3 companies, let's compare and contrast how effective will this implementation be as a real world laboratory for experimentation. Many partnerships, examples of the oil companies knocking on our door. Shell just launched a 10 million accelerator program with startups with NREL, where the research lab can support for 40 to 80 hours different startup company ideas, validate, introduce them to new markets. Exxon invested 100 million in advanced biofuels, primarily looking at aviation. decarbonization of the aviation sector, Wells Fargo Foundation, and others. I'll just say we're moving from food, energy, water, few, to many sustainable cities is our goal. This was a conference I presented at the week before I started at NREL, and many of these partnerships are still emerging. I'm just sharing a few slides here of our world in 1980. We've actually, every 10 years, added about 6 megacities, 10 million plus population. And I've worked in 7 of the 10 largest, and I'll say these are important and complex contexts, but I actually think for our ability to be successful on some of these sustainability challenges, we actually have to look beyond the megacities and the places that are the financial and political capitals of the world, and I think small, mid-sized cities are actually where the action is going to be. 60 to 70% of the world's urban population are in these small cities that are rapidly urbanizing. The mega cities represent less than 10% of the world's urban population. And these small cities lack the same financial, political, intellectual capital. Not going to dwell on this too much, but there's a lot of interlinkages that we like to explore. A good example of Israel, they tripled their population, 9-fold increase in food produced with only a 3% increase in the use of water. Can the US learn from this in the Southwest, where we actually divert water back from the mountains to the east where it's rapid population growth in Denver? California and Mexico no longer get their fair share of the Colorado River basin. It's over-allocated. You can make a lot of money as an environmental lawyer figuring out these challenges during drought periods. And I'll just say, NCAR, we were a 2-3+ person team. We drew on a global network working at these different scales. The NSF PIRE was a project that had 4 different themes. We looked at with a very interdisciplinary team of engineers, social scientists, environmental scientists, public health. This premise of megacities are smaller in the grand scheme of addressing urbanization challenges. I'll say the smaller cities we looked at in India, 1 million in population, doubling to 2 million in, I want to say 12 years. The motor vehicle population is doubling in 4 to 6 years. And so crazy amounts of building of flyovers to solve traffic congestion and locking into pretty challenging types of Western development models that may not be so sustainable in the long run. So a broader focus on the social sciences has always been my sort of lesson learned. We often lead with engineers, physical scientists. We tack on the social scientists at the end. My experimental approach in being a postdoc was, what if we have a sociologist lead and I support as an engineer, and I'm out of my comfort zone, but I'm taking an approach of empathy to try to understand the world from her lens of how she's approaching these transitions. This is our RCN. That was another good example of a funding opportunity where you coordinate research between different teams. You have workshops. It led to a 12 million sustainability research network for my PhD advisor, and then she led this recent report on articulating the long-term convergence research agenda for sustainable urban systems in the US. She's now at Princeton University as their chair for India, cities, and urbanization. If we look beyond 2100, 2200, we will potentially triple the developing world's urban populations. A lot of this urbanization is actually not happening here in Philadelphia. It's in the global south and emerging economies. And that's where I think there's going to be a tremendous amount of demand for engineers. There's a quote, 75% of the infrastructure that will exist in 2050 has not even been built today. And you see people like the president of Carnegie Mellon actually moving over to Asia with this sort of, there might be a repositioning of where is the most important work that's happening globally. Transportation, sorry, it doesn't come out well. This is my uncle who's in the transportation space. He wrote a book called 2 Billion Cars. He's at UC Davis, directs their institute there. We have 1 billion motor vehicles in the world today. Within less than 15, 20 years, we'll have 2 billion. And so how do we transition in a way that makes sense? And now with all these micro-mobility, Lyft, Bird scooters, and so on, we need to think about how we transform our vehicles, our fuels, as well as our behaviors. I'm going to skip over. This is one slide from my PhD. I looked at in Delhi, India. Rather than think about climate change, I think someone mentioned we start to think about, once we have enough income, we care about global problems. When it's still, I need to provide for my family basic services. They call it the brown, the gray, the green agendas. Brown is it's very localized, as an environmental challenge. Sanitation still an issue. Gray is you're starting to industrialize, it's more regional environmental issues. Green, you're affluent already, and you're starting to care about global environmental concerns. So we saw those agendas mixing in India, but I took an approach of, okay, let's focus on the very local. Rather than just telling India you need to decarbonize based on the US seeing issues and how we've approached things, what's killing people today? What causes of death could be related to a purview of a civil engineer or an urban planner? We know air pollution is a pretty big one, cardiovascular, respiratory issues, water sanitation, related to traffic fatalities, to even pregnancy and birth. We saw a tremendous number of deaths that were under 5 children. And a next chapter I wrote was looking at USAID data that showed if we provided, and this is the nexus, water, electricity rather than solid fuels on premises, and a toilet on premises, if we provide all 3 of those things to controlled groups of low income, low literacy, lack of access to health care, you're seeing a 60 to 80% reduction in under 5 mortality compared to if you just do a single sector intervention of just water supply or just a toilet or just electricity. It's somewhere in the range of documented evidence of 7% to 13%. And so the idea is when we take cross-sectoral approaches, can we achieve even greater impact on just improving health of children? Okay, that key message, I'll end. I have 10 minutes left. I want to do that exercise. I'll just say this proposal I just led up, it's NREL, it's NYU, it's the Water Research Foundation, together with 3 cities in Israel. And we're looking at artificial intelligence, machine learning driven approaches to optimizing process control based on different qualities of water. We have partners at New York City DEP that manages 17 wastewater plants in New York. They have a 100% renewable electricity goal in New York, in Colorado, and California by 2040, 2050. We're asking what does this mean for wastewater systems and water security? Denver Water, Metro Wastewater, and maybe LA DWP. LA is a municipally owned utility that manages water and energy. They're working with NREL on 100% renewable electricity by 2030 to showcase and advance the Olympics and being the electric mobility hub of the world, as today 40% of all electric vehicles nationwide. Leveraging finance, some of the key people, I mentioned Patty, my colleague, she's just above me there. We have he was the head of the EPA drinking water team, now at the Water Research Foundation. My colleague Jennifer, who worked on wastewater treatment plants for 20 years. Ariel came from, he's a postdoc that just joined us, worked on energy, water, climate modeling, a microgrid professor from NYU, and then several others that I think we've built a pretty exciting team here. Industry, TAS. This is our campus. It's a beautiful location. We have the world's fastest supercomputers in that building, together with Oak Ridge and other locations. So just what was mentioned about data, I remember a question earlier of efficiencies are important, but we're actually, as a net zero energy campus, our biggest challenge to staying net zero is the increased data and data center usage, and we're actually taking the heat and capturing it for district heating around the different buildings, but it's still making it really challenging to stay net zero. And I think there's one other campus, California Air Resources Board, that's now the world's largest net zero energy building. A lot of testing there. I mentioned this. We have this is worth looking up. DOE launched a Water Security Grand Challenge, where it's different prize competitions that university student teams can engage in. The one, number 4, is this, essentially the idea for this Israel proposal. 5 is that renew concept, small modular systems for urban, tribal, disaster response settings. Desalinate, they asked us by the Israel reviewers last week. I was able to get my colleagues on at 7 in the morning and 6 a.m. in California. But they said, you just got awarded $100 million. Do you really need this $10 million additional award? And we'll see what happens. But we said we didn't know we were going to get it until the day we submitted this full proposal for the Israel. And our idea was actually to say, we shouldn't spend $100 million on desalination. We should spend $100 million on wastewater reuse first, and $10 million on desal, because it's going to be much more widely available for addressing water security, water scarcity. And this desal is much more basic science. DOE has these technology readiness levels on a scale of 1 to 9. 2 to 4 is more basic, in the lab, pilot testing. 5, 6 is in the real world, pilots to 8, 9 is widely commercially available and deployed across the nation, across the world. The map there, you can look up Nawi Hub. This is our network for the desal hub. It's just kicking off. The first 6 months is sort of the technology roadmaps and R&D, and then there's going to be a public RFP for different teams to apply for funding. This A prime is an acronym of the types of characteristics: automation, precision, separation, resilient treatment, and so on, modular, electrified systems. With the Water Research Foundation, we just published a report on distributed energy microgrids for water wastewater. Here's some drivers, here's key challenges, water stress. We have an innovation and entrepreneurship program that essentially allows startups to work with us from universities or cities. An industry growth forum. A lot of exciting stuff happening. I think I'll stop. Industry partners, this is a group that we came across through the State Department when we were pitching this prize competition for Renew. They were leading a project for the MacArthur Foundation, a Circular Economy 100 initiative. How do you achieve market-based or business approaches to the circular economy? And he's calling it an integrated utility hub, a colleague in New York. This is the LA project, which is exciting. It was after the Trump agreement we pulled out of, or sorry, Paris agreement we pulled out of. 120 cities, states came to I've heard the quote, politics now trumps science. And so I think we're out to prove that it may be the other way around. And I guess I can't always say certain things on video, and that's where even my wife said, be careful with what you communicate in the current administration. We can't actually publish saying the words greenhouse gas emissions, climate change right now. So we have to be really careful with our use of words. Economic competitiveness, resilience works, efficiency, infrastructure modernization, cybersecurity. I'll stop there. I'm going to have each person talk to the person next to them. I brought up a lot of challenges here. I want to hear just from 3 different people in the room a really big problem that you think is important in the urban context, and I'm really interested in learning more about materials, that part of the solution space that I'd like to. I know I have material science colleagues at NREL. I went to meet with them before I came here saying I need to understand my audience better. They had more questions for me, and I didn't get a chance to really dive in deeply, but I'm sensing that there could be nice collaborations between NREL and UPenn. That could be in the material sciences, but also around some of the broader areas I described. And happy to always help universities navigate the DOE funding landscape, which I think can seem like a black box. And sometimes we know the language and priorities, and we can't lead, but we can support. And it usually starts with a 2-page concept paper. If that moves forward, you write a full proposal, but you're at a stage where you sort of have a 1 in 3 chance at that point. So it's a little more lower early effort. So next, your name, who you're with, and one big problem, and how you would take at least a 2-pronged approach between your disciplinary backgrounds to solving that issue, knowing that not either one of you will have the silver bullet single solution. What's at least 2 parts to the strategy that you would take on together? So take 2-3 minutes there. And I want to hear a few of the processes that you come up with. All right, so we're going to close up here. I know we only have 2-3 minutes left. I don't want to get us behind schedule, but I do want to have at least 2-3 people raise their hands. You're not going to solve the world's problems here, but I want you thinking outside the box, and I'm also happy for anybody that thinks they're onto something with their partner here. I'm happy to take that on as NREL. Email the idea or the process, and I'm happy to map to 1 or 2 key colleagues. I can't take everything on myself, but I do like these. I started with Engineers Without Borders as the first sort of human-centered approach in undergrad. The founder was from my institution, and he was the first science envoy for the US in the Obama administration, trying to create peace through engineering. And in the early stages of this, we would meet with different universities, and we grew from 30 to 50 as an annual conference, 80 people, to 15,000 different engineers across the whole US. A chapter at most universities and professional chapters in many cities, working in 80 different countries on just improving basic services. And so I do see the power of our chief technology officer at the White House, the first female, Megan Smith. She called it crowdsourcing genius. And so I think the power of each of us together is much more than any of us can do alone. So I'll take 2 or 3. I'm going to put the students on the spot, so I'll start in the very back. Maybe in the back right side here. We'll do middle left here, and then maybe, I don't know if we have any students up front here, but maybe from the city's perspective of getting that, while we have our international guests, getting their thoughts. So why don't we go ahead in the back.
All right. So one problem I was thinking of is just, because it's winter out and we have the snow accumulating in the cities, is there a more efficient way to remove the snow from the cities, or even better, to prevent the accumulation of snow in the streets? That's not salting the roads, where the salt can then be runoff into the environment. Snow plows would also be environmental impact. So if we, I think you mentioned earlier, thermal recapture from the buildings, and somehow cycle that into the roads to prevent the accumulation of ice, or design new materials that prevent ice accumulations on the streets.
That's great. All right, let's keep talking. I think this would be relevant to France. And our ski resorts also heat the sidewalks and pavements, and we don't like to put salt down. And my wife actually, rather than our next car being an electric vehicle, which was my goal, she wanted the Subaru Crosstrek for the safety of our young one on the roads. And they don't salt at all in Colorado. They just expect the sun to come out the next day and melt it all. So, all right, that's great. Did you want to add to that? Go ahead.
So we're chatting about I've heard about everyone kind of put the idea about how to produce new energies, how energies are produced, how we can be able to provide sustainable energies and smart urban environment. But in the process of these productions, we also accumulate waste that we don't talk about. Like we've been sitting here and nobody's talking about what is going to happen to the waste that is accumulated over time. And you work with the DOE, you see that one of the major challenges with the DOE is the accumulation of waste that the DOD has accumulated over the years, like what is happening in Oak Ridge. And that's the challenge that they are facing now, 50 years down the road, because nobody thought about it. And even at the DOD now, when we design products, we don't really kind of overall think about what is the impact 50 years down the road. We kind of think about what is the impact of now and how we can be able to make it smart.
Yeah, we call this whack-a-mole. If you're at the amusement park, you're hitting the problem of today, and these 2 or 3 other problems pop up. And so unless we're thinking about those unanticipated consequences, I have a colleague I should put you in touch with. Feel free to email me. His name is Garvin Heath, and he's leading our Circular Economy Strategic Initiative on battery recycling, PV recycling, and I think of just every university campus probably has tons of old computers, electronic cell phones, and so I think waste is always going to be an important area to address. And DOE is investing in battery recycling, secondary uses for batteries. A whole secondary market maybe in locations. The African Development Bank, the urban team, was very interested in us looking at which port do they import from for hybrids or electric vehicles that are secondhand, not knowing that there's any clarity in terms of they could charge 10 times as much at this port as an import tariff versus 3 times. And so just mapping out what are the costs across the different locations of Africa to import hybrids first and then secondhand electric vehicles. Okay, we'll make it quick. Go ahead.
Sure. Hi, my name's Steven, and so we were talking about over here incorporating more energy harvesting solutions on current infrastructure inside the city. And so, for example, like on tops of buildings, a lot of the space is unused and can be tapped with potential for solar panels or using it for rainwater collection, for harvesting. And then there's also like more larger structures like sidewalks and roads where you can incorporate materials like electrics or some heat harvesting, something like that for cars or people that walk.
That's great. So I think this is a very materials-oriented. It's actually making me think of a few different touch points. Lawrence Berkeley Lab has this Cool Roofs program. What if we painted all roofs white? To my PhD program, we had structural engineers looking at recycling fly ash into cement and concrete. China's used more concrete for construction in the past 3-4 years than the US has used in the past 100. And so can we think quickly about new types of materials that might be lower carbon or addressing this trade-off space of for energy generation on the rooftop versus food production or just cooling? That's great. Okay, so to the experts, the city practitioners from Korea and France. Could we get your thoughts or perspectives? It's almost bedtime, right?
Two ideas that I'm a researcher for the French National Center of Scientific Research. They're asking us more and more to think about two types of ideas. Self-healing materials for functions. That's something that is really interesting, just to postpone the test of this material. The other one is chemistry nurture, which is very scientific. But I mean, try to invent some generic solution. Just not a process or a product that has one specific target can be then just implemented so that we not start back again from scratch for the next product.
That's great. I have to learn more here. You're going to have to educate me. Appreciate it. Thank you.
I will need your help for that.
Any thoughts and perspectives?
I think that one of the most serious environmental issues is what we do with PM10, and we have transnational influence which is very seasonal. So we have to have very flexible policies and see here the next solution to work.
Yeah, I think cities around the world, I give Delhi because that's where I was, but the year after I left, it was the world's most polluted city. And the seasonal challenges are very clearly yeah, I think of my colleague, he was in India the year before me, he's at UT Austin. He's harnessing technology from Google, self-driving cars in Oakland and Austin. He's having them collect data in real time going around the city for air pollution monitoring. He says, I'm getting so much data, it's interesting, but I'm boiling it down to one insight that I'm going to publish. Trucks turning left. They're waiting at an intersection, at a port, or at a construction location, and we know UPS actually set up for fuel efficiency and emission savings 3 right turns rather than a left. But he's trying to prove out that we should have all trucks just take 3 right turns rather than a left. Yeah. Anyway, well, I appreciate everyone's thoughts, ideas here. I think there's probably many more. I'm looking forward to continuing to learn, and thank you so much for having me. And I hope we get to continue to shape a better world together.
Great.
Well, welcome back, everyone. My name is Angela Pachon. I'm the Research Director of the Climate Center for Energy Policy. And I want to thank Ross and Kristen for the invitation, and also Kristen for the amazing organization of this event. As an economist, I'm not an engineer, and this is an audience of engineers, but as an economist, obviously working in energy and climate policy, life can be frustrating, and I suppose these days it can be frustrating for anyone listening the news about politics and policy in climate and energy. But that's why it's so thrilling for me to be here today, listening on the way how technology can really help to solve the most pressing problems. And because after all, good policy should be based on basic science and applied technology. But given the way that, the nature of these pressing problems that the world is facing today, so we require these solutions. And as we heard from Josh in the previous sessions, those solutions should be multidisciplinary. And that's the reason why we are here today, because, I mean, we have an audience of engineers, but in this panel, we're going to have practitioners that can tell us their experience firsthand about implementing technology and how the cities may be solving some of these challenges. We heard this morning examples in South Korea, in France, in the city of Philadelphia. But in this panel is really about, I mean, what practitioners face, and so that obviously engineers can take notes and see what are the other phases and aspects of these challenges that maybe you are not familiar with. So to start the panel, I'm going to briefly introduce the panelists. I mean, you can see their titles up there, titles and beautiful pictures up there. But so we have from South Korea, and you have the opportunity to listen to him this morning. We have Professor Kyung-Hwan Kim. He is professor of economics at Songgang University and former Vice Minister of the Ministry of Land, Infrastructure, and Transport for the Republic of Korea. Then we'll have Chris Puchalski. He's the Director of Policy and Strategic Initiatives of the City of Philadelphia for the Office of Transportation, Infrastructure, and Sustainability, OTIS. And he is an engineer. He is an engineer, but he has his PhD in urban transportation system engineering from Penn. So welcome back. And finally, playing the local, we have Howard Newkirk. He is the professor of practice in water leadership and innovation here at Penn, and he is the founding director of the Urban Water Center. He has over 40 years of experience in the water industry, and he was the CEO of Philadelphia Water, and he is also an engineer. So welcome.
From Penn.
And from Penn also, welcome back. So we're gonna start it's a way also for you to talk about the work you do, about your experiences of cities implementing innovation. Can you, provide examples of your life as practitioners? If you can tell the audience examples of how can cities really solve these problems by introducing innovation and technology?
Sure, I'll start. So welcome to Philadelphia. If you haven't already been welcomed, I believe my colleague Ann Fadulin came and spoke to you this morning. So I think that's a difficult question because innovation comes in all forms, and some of it is very early in the innovation cycle when something is tried in a municipal environment, and other times technologies are pretty well developed. In the last presentation, there was a reference by Joshua to the technology readiness levels that I think NASA first developed, and sometimes, especially in a more well-resourced city, there's an opportunity for innovation at a lower technology readiness level. But often something is, by the time it can be implemented, especially if it's anything systematic, not just plug and play kind of switch, it really has to be at the 8 or 9 level before it can be implemented, especially on a wide scale. So that just brings its own set of challenges. I'll give you an example. Asphalt, there's streets all around you, and we pave about 100 miles a year, at least we did last year and this year. There's recently a technology called warm mix asphalt that is going to be implemented here in Philadelphia for the first time. But that had a 20-year development cycle probably when it first was being tested in the real world, and it was already standard by the time it got to be implemented elsewhere. I'd say a lot of the innovation, especially that my office does, it's really about best practice work, especially in a city like Philadelphia. We're the poorest large city in America, and we just don't have the same kind of resources that other cities do. So we that's both a detriment and advantage. We often have second mover advantage. We see all the mistakes that everybody else makes, and then we try not to make all those same mistakes. Only, if we can only make half of them, then that's a victory. One of the things my office is doing is trying to put in new street level treatments to encourage cycling, and that's often taking the best practice from elsewhere and really finding how does our unique context in our city require a change in those technologies, or at least a different way of communicating how it can be applied in our system. So I can say a lot more, but
Howard?
Yeah, I'll just build on what you were just saying about asphalt and 100 miles, 100 miles of streets being paved each year. Seems like we need to do some more. I'm not sure, but
we do.
We do. The water department, we're very much about water, and we experimented by taking 25 of these blocks and doing porous asphalt, which is a technology. It's very simple. We're trying to take rainwater and put it into the ground. And it turns out that in an urban setting like Philadelphia or anywhere in the world, it's not such an easy thing. So we've been trying around with porous asphalt, but it's another. That's just one example of the office of transportation working with the water utility, trying to figure out how do you move on to this next generation of unfortunately for streets, because we're not yet at the point where we're thinking about removing parking lanes or driving lanes or moving more to mass transit. What I really wanted to talk about was this group that I chair. It's called the Global Water Leaders Group, Leading Utilities of the World. We formed this group about 3 years ago, and right now we have 50 of the most innovative public water utility CEOs in the world working together in a network. And each year we bring on another 10 or so utilities into this fold. And what we ask them to do is to identify 3 of the biggest challenges that they've had over the last 5 years and the innovations that they've put together in order to solve those challenges. And we've got 14 different categories things can go into: IT, smart systems, infrastructure, water scarcity, all different kinds of issues like that. And it's amazing to watch these groups and to understand how you can, by doing this and presenting it to each other, you can form alliances and take knowledge and just really identify what else is needed. And my favorite example is Singapore is part of our group. The group's from all over the world, but Singapore is one of the early utilities to join us. And Mr. Ng, who runs the utility there, because they're so innovative in so many different ways of urban life, but in water, they're really known as one of the best in the world. And I said, Mr. Ng, how is it that you're so innovative? And he looked at me and he said, Howard, if you had no water, you'd be innovative too. And it really turns out that, some of this discussion about water and is it available and what are people doing about it, a lot of it is crisis motivated. A lot of the innovation that you'll see both in Philadelphia, crisis with EPA regulations forcing us to do certain things have turned us around in crisis mode to go to a Green City Clean Waters program. So a lot of the innovation is happening that way, and I'll stop now, but we're going to continue that conversation.
Yeah.
First of all, I do not represent the government of Korea or the Seoul Metropolitan Government at this particular point in time. I served in the government. I had taken a role of policy advisor for a long time. I also worked for a UN agency, now UN Habitat, a long time ago. Now, if you think about this adoption of new technologies, I think it's context-driven. It depends on which country and which city you're talking about, and it's time-bound. The technologies that used to be too expensive to be applied now become affordable, and some of the technologies become more feasible because of the developments of some other things that have an indirect impact on these technologies. So I think there is no single rule, but we need to be very flexible and agile to respond to changing nature of the problems as well as the solutions of being available in different points in time. In the case of Seoul, it's a very densely populated as a nation. The Seoul is very, very densely populated. So it's, in that sense, it has an advantage of wiring the whole city. It's much easier. That's one of the reasons that internet is so widely being used in Korea in general and Seoul in particular. And that helps introduce a lot of internet-based technologies and applications. But that's not necessarily true in more sparsely populated cities elsewhere. The second point is that cities tend to compete with each other and learn from each other. It's a cross-nurturing process. Now, the ministry that I worked for worked with the American Planners Association equivalent to Korea, which is a Korea Planners Association. Every year, they evaluate all the cities in terms of a given set of indicators, including some indicators on sustainability and resilience and inclusivity. And then they get this data from, it's mandatory to produce a basic data for every city. It's mandated to produce the data every year. And this panel of examiners commissioned by the Academic Association pays a visit to a shortlisted cities and identify the strengths of the city and whether what they claim is really up and running and on the ground. So, and they select top performer and runner-up and so on every year. And that gives a chance for each city to learn what each other city is doing. And there's also a network of city mayors. I think this is true in virtually every country. And there's the league, it's a network of planners and a network of city treasurers and so on, so that they can learn from each other. I think it's important to learn from successes, but it's more important to learn from their mistakes. So, we have to be always on the alert and be ready to rectify our mistakes. And if I make one further comment, energy mix, this has a long-run impact, long-term impact once decided. Mm-hmm. And I'm not a specialist in this. So there were times when clean diesel engine was widely promoted. And now we say we need to get rid of diesel engine cars from the streets. So now in Korea, in this downtown Seoul, the obsolete diesel cars are banned to enter, or they have to pay a very heavy penalty. But then they argue, well, the government at one time promoted diesel engine by subsidizing fuel and other incentives. And now, it's a completely going in the other direction, right?
And so I think the three of you mentioned an important point, which is, collaboration. You try to see what others are doing, what are the best practices. But I would like to know your view on the different, the competing responsibilities of the city, because obviously you can see these best practices and be willing to innovate, but when you have all these other demands, how can, do cities really have the possibility to innovate when they have such an amount, for example, upgrading infrastructure, which is, I mean, a big issue for American cities, how can the cities can balance these different demands?
Yes. So, for any given executive in the city government, it's my sense that there's a whole list of day-to-day responsibilities. So, for the water commissioner, Howard knows this probably better than I. If a water main breaks, that might be the most important thing today and tomorrow, and until that gets fixed. And for the sanitation workers, it's getting all the trash and the recycling picked up, and for the streets department, health department, so on and so on. So there's these daily operational pressures that are kind of can be so out there that it's really hard for innovation to find its way into the practice. That given, if you add on that innovation is just inherently risky, right? Otherwise, it wouldn't be innovation. I get to serve on this panel that advises the Federal Highway Administration on their research agenda, and they were telling me that once a senator once asked, well, why don't you just pick all the technologies? Why do some of your research projects not work out? Why don't you just pick all the technologies that are going to work out and only research those? I don't think he understood the whole technology development process, because these things are inherently risky, and to find their way in, that they get the oxygen in the room to be able to develop for whoever it is to take a risk. Generally, there has to be a crisis, I feel, in order for something new. Or there's sometimes there's exceptions. There's very innovative leaders or empowered bureaucracies that are able to innovate. But generally, it takes some really strong outside forcing function like a crisis to really get the innovation to happen. Otherwise, that whole host of other issues that are taking up the executive's time or the mid-management time will force out innovation.
If I can just take that and just twist it a little bit and say that, yes, crisis is so important. Yes. It's so important to everything that you do in government. But you need that leadership, you need that vision, you need that planning, so that when the crisis comes, you're ready to pounce on it and make some progress out of that. And at Philly Water, where I think it is one of the most, I think of it as one of the most innovative water utilities in the country, which means in the world. We got really lucky because we fell into this Watersheds Green Cities program. And what happened was it was, instead of, whenever we went out to recruit for engineers, we would get a few engineers who were interested in coming and designing sewer pipes or water pipes. All of a sudden, the floodgates were open, and young engineers from prestigious schools like Penn and elsewhere were suddenly willing to come to us for low pay in order to change the world. And so part of this is really just taking that, being able to raise that vision, that leadership, that perspective, and let people run with it. Now, and then what happens there is now you have 100 people who are just in the process of turning 30 or so, a little younger, a little older, and they are now taking up leadership roles within the utility. So affecting change through who comes in, who your people are, what you're asking them to do, and is really critical these days, especially when you have so many people my age with 40 years experience who are just looking to retire.
I do share with the view that when we are pressed really hard, we are bound to come up with some solutions. And history is proof of that. But on the other hand, we need visionary leadership that goes, that can sort of take the leadership in making tough choices and implement them. Now, regarding this, we talk about technological innovation and solutions, technological solutions, but there are economic solutions that could be more effective in changing the behavior of people. We talk about energy issue, we have water issues. We need to provide additional water, additional energy to meet the demand, but we also need to work on the demand side to manage demand. And their pricing is crucial. But this is something politically very dangerous to touch upon. So you talk about congestion. I mean, the best solution, economically best solution, is to charge the use of the roadway. But that's so difficult, right? With global warming, and you need to get people out of the car. What works best? Raise the price of fuel. That doesn't work. Now, so if you think about this congestion charging, technologically it's not difficult. You'll be really surprised to know that William Vickery, who is a Nobel laureate from the Columbia University, he came up with a detailed plan to introduce sort of electronic version of road pricing back in 1959 when he testified in the Joint Committee in Washington, D.C. to solve the congestion problem. So he did all the calculations of, even how many printers are needed, but it took many years that the idea was finally implemented in Singapore in its rudimentary form in 1973, and now Singapore has an electronic road pricing scheme that works very well. They started in 1998. Other than that, London is the only other place that is serious. And that was because Mayor Livingston made a campaign pledge which appeared not to be very popular, and he got elected and implemented it. So many cities discuss the possibility of introducing this. It's no longer a technological issue. It is a political will, and it's the ability to convince the people this is something that's good for the environment and efficiency of the economy and so on. So my point is that we need to look for technological solutions, but we also need to work on the economic incentives to make the technology work better.
Economic incentive and also policy tools,
Exactly.
I imagine, because obviously as cities may not have, may be restricted the amount of policy regulations or regulations that they can establish, but anyway, they could help the introduction of technologies in some way. So in your view, what is the role of regulations, standards, incentives, or even bans on certain sort of issues? Can cities have a role to play? Or, I mean, in some sectors, we have the federal role that should play a role, but when that is not happening, in your view, what is the role of the cities?
So, we're almost always going to argue for more local control over our future. It's about every week that the Republican-dominated legislature in Harrisburg tries to take away something that the city of Philadelphia wants to do or doesn't want to do. So, we generally think there should be more local control. I think it's hard to answer your question in the abstract. I think there's some specific examples. And I think the ones, whether it's, regulating something, providing an incentive, banning something, it's generally when it hits multiple policy goals is when that's a winner. And it can be communicated to the populace in a really succinct way. And I also think it really helps to fail several times before you succeed. So whether that is the soda tax that Mayor Kenney passed, which is not only fighting obesity in communities that are really struggling with some health issues, but it's also funding parks and rec centers and libraries. or it's banning plastic bags, transportation funding initiatives across the U.S. that are regional and urban in nature. They almost always fail one or several times, and a coalition gets built, and then more and more people understand what's really going on here, and the message gets refined. So I think this process of policymaking. Congestion pricing in New York. That failed. About a decade ago, around 2008, before it succeeded last year due to a crisis in funding for the subway network in New York. So these things often take, not just once, but several times over a decade. London, it took studying it for 40 years in order for it to be implemented. So it takes a while, but I think there is a strong a strong role that city government has to play in cooperation, but I think the policy really has to be smart and developed in order for to step out and get the political buy-in. Combining good policy with new technology.
I think more to
My view of the world is that the one great thing about working in the environment and working in water and working in urban systems is that there's so much to do. There's just like anywhere you look, there are things you need to improve. And with that, you can pick policies that can be enacted on the local level or the federal level, because the locals, cities have a lot of say, believe it or not, in what happens on federal legislation and regulations. So you have this ability to really play both sides of this and to pick and choose in Philly, we turned rainwater into a commodity. We play around with how we charge for water versus wastewater. Of course, we can pay for both of them. There are a lot of different ways we can do this, but there is this politics. There's that. I just want to go back to the politics for a second, because almost every water utility in the country bases their budgets on their rates. On the water rates. And the water rates should be based upon the budgets. Budgets of what you need to do to implement and create resilient and sustainable systems. But that doesn't happen in the US because politics gets in the way, local politics, which prevent the water utilities to raise rates sufficiently in order to be able to pay for what's really needed in our system. So a large part of our aging infrastructure and the water systems, and probably the same thing with the streets and with the bridges, is this problem that it's not that we don't have enough money, it's just that it's not being allocated to the right things.
Yeah, there is no connection between the revenue that the streets department, for example, gets and the needs, of it, either from the state or elsewhere. I mean, there tries to be, and I think we've made a case, and the paving went up from 40 miles to 100 miles, but that's still short of what's really needed. So it is a challenge.
Yeah. I think it's not unique to the U.S. Subway fares, bus fares, water tariffs are very difficult to raise because they're considered a necessity of life, and there is an equity issue, which actually can be dealt with in a smarter way, but it's always difficult to deal with. Now, regulation are slow to adjust, and they fall behind the pace of technological breakthrough. Now, but nevertheless, in order to make technology work, you need to modify some regulations, rewrite the laws, and so on. Experts tend to complain about this for good reason. It's very frustrating, but you cannot change the world without convincing the politicians or working effectively with the media. Whatever good product you have in your hand, if people don't believe it, that's nothing. And it takes patience. It takes skills. You need to communicate better, more effectively. And when you find the right champion to promote a new technology or new policy idea, then you can make a breakthrough. So I think that one of the most important roles of experts like us is to help politicians and government make better informed decisions. And that doesn't stop at providing the solutions themselves. It goes beyond that. So we have to learn how to communicate more effectively with the citizens directly or through the media. But we also need to become wiser in dealing with politicians. I mean, that's the reality. We cannot get around with that.
And this is an excellent point. I may compliment here. We have a clear example at Kleinman. We have been working with Shuyan. I don't think she's here. She's doing amazing research to have new materials for windows. Mm-hmm. But windows in this country are, I mean, buildings represent an enormous amount of greenhouse emissions. And you may think, I mean, clearly to save energy, having very efficient, energy-efficient windows is a no-brainer. But windows in this country require to be adopted by codes, building codes. Mm-hmm. And these codes take, I mean, to renew the renewable or the inception of new materials in those codes could take ages. So even if the technology has been developed and it can be proved and is at scale, then if there is not a complementary work with the policymakers deciding on these building codes, it's very difficult then to implement those technologies. So that's an excellent example of how researchers need to work closely and to inform whenever, I mean, policymakers may not be even aware that there's a need to update the Windows section of the code, but that's something, those dialogues need to happen in a more systematic way. So, and what you mentioned is true. It's very lengthy the way regulation may adopt.
If I may add just one quick point, any innovative solution creates winners, but also losers.
Losers, exactly.
And unless you effectively deal with the losers, you cannot make that happen. It's like, let's talk about smart metering. It makes a lot of sense, and it will help a lot of people. However, some people will be fired or laid off as a result of this. So so we need to find a way to deal with this. Sometimes real, sometimes a perceived issue, but again, that's in the realm of public choice.
Yes, and that's it.
Yeah, just a question about the codes that take so long to change. Where did that come?
What?
The building codes. Why is it so long to change them? Why does it take so much time?
Because these are the reference for the whole building industry, and just for a city to change it has to have an agreement on many stakeholders. And so once that's agreed, they expect that to last for several years. So which means that any innovation that may come sooner either may have to wait or may have to really lobby to have these codes to be reviewed.
It's largely a political. It goes back to politics. It's the unions and their needs, the building developers and owners and their needs, and there rarely are sufficient people with enough political power to take Shu's good work and get a change in policy, because there's no what I've learned is the term is constituent. If you're a winner, you're nobody's constituent because you don't care. You're just like off to the side. But if you're a loser, you are a major constituent for the politician. So but there are ways around it too. There's it's illegal in Philadelphia to disconnect the roof leader that takes the drainage from the roof and goes into the sewer. it's illegal to disconnect it, and part of our programs is to disconnect them. And we couldn't get the policy changed, but we did get permission to get a waiver because we were doing a pilot. Every disconnected roof leader in the city is a pilot. And with that, we're allowed to do it.
Yeah, and adding to the codes, when you think that every city may have a different code, which means if you want your innovation to be able to be deployed at a national level, you may have to work with a lot of people. And that's why there are big lobbies that do it for the industries. But thinking about this process, I think it's important when developing, the full stage of this innovation and research.
It's almost like getting a new drug approved, I would say.
Yeah.
It's not enough that in a small sample it showed efficacy. It's not even enough that in a large sample it showed efficacy with few side effects. Mm-hmm. It's got to be everyone's got to be comfortable with it, because there are enough counterexamples, and you can only imagine if the window, any of the ways that a window could fail, that would be terrible, right? And that's what the people who are in charge of these things, it's kind of their job to worry about it. Okay, how are all the ways this new technology can go wrong that are gonna kill somebody, right? Or be bad in 8 other ways. And then, even if they're just like red herrings, they generally all get considered, and they're generally suspicious people. So I think they have a role in our society, to make sure that there's things that are appropriately tested, and I think you all and innovators have a role in our society to push the envelope. And I think it's that kind of dynamic back and forth is when things happen. But just think of the window suddenly breaking on a super cold day, right?
Yes.
Oh wait, we didn't. We only tested it, in these 8 different environments, not this 9th environment. So, anyways, you can understand for all building materials and codes why they're really important.
I think it's an important point, and civil servants are generally risk averse. Mm-hmm. So they have to worry about very small risk of big accident happening, right? If things go well, they will not be sort of praised for the new innovation they introduce. But if the new innovation goes wrong, you have to bear all the criticisms in it. Maybe you lose a post. So in Korea, there's a national board of audit, which looks into the sort of misbehavior of civil servants at different levels, and the government has made it an exception that if a civil servant with a good intention makes a sort of more proactive choice, and then something bad happens, the person be given immunity rather than being held responsible for the mistake. But it's there, but still, it's difficult to change the behavior of civil servants. So.
And probably one of the most important things, and I think this goes to a lot of what Josh was presenting, is that there are 3 different big elements out there, and there's there's the practitioner and what they need and their risk level and et cetera, and then there's the academic researchers, and then there's the technology companies. Mm-hmm. And all 3 are not talking to each other. There's no communication amongst them. And a great example is we had a conference. We had this group. We had the CEO of IBM and of Xylem and et cetera, talking about what they have, their greatest thing for the water industry. Mm-hmm. And we're all us water utility guys are just sitting there going like, okay, it's nice, but it's not our priorities. These aren't hitting on our priorities. And the next session was the utility leaders up there. They had a session called Uninvented Technologies. What do you really need? And my favorite was the guy from Anchorage, Alaska, who said, I need to know where that water pipe is leaking so I can fix it. And I need to know that in the middle of the winter, when I have 10 feet of frost above that pipe and another 10 feet of snowpack on top of that. I need to dig once and get it right. You know, so when you start talking to practitioners, it may not be sexy what they really need, but then again, it's the things that, if you want innovation to be applied quicker, you need to listen to what the practitioner is looking for at that time.
And so that's I mean, how, because you mentioned, I mean, private sector, academia, the city, but who is best positioned to deploy these technologies? Because obviously in the water sector, it seems that utilities are still public owned and there is a lot of political interference. In the energy sector, that's not the case. There are a lot of private entities, and we have seen that, I mean, in some way they've been forced to competition. Like now you have the Google and Amazon of the world offering system for the smart home, which may control your energy efficiency at home, something that the utilities wanted always to be in the market for. So what's the role of the private sector? Because obviously they can help first to develop, but in terms of implementation, how can they work and this private-public partnership with cities, how can this work to deploy innovations?
It's hard because private sector charges more. And we'll go back to that very beginning here. It's all about economics. It's all about the price of the commodity. And why doesn't the water system have special little conservation efforts all over their smart homes? And because it's not worth it, and we will get it, but first the electric industry is going to do it, and then the gas industry, and then that same innovation will be transferred to the water sector. But right now, the water sector is the least valuable to anybody who's paying a $50 bill for water, wastewater, stormwater, versus $150, $200 for electric. So the economics really comes in almost at every level here of what you're talking about.
I think the companies that have a good technology, that they've actually listened to the needs of the public sector and the infrastructure world. I mean, they have no troubles finding us. I get several emails a day for solutions to problems I don't actually have. So, but I think this points to an important federal role in research, especially at those mid-level. At those mid-technology levels, above I feel like basic science could always use more research, but it's not, we at least have, reasonable basic science research. It's kind of getting that like 4, 5, 6, 7 technology readiness levels, taking the basic technology, proving it on its own and then proving it in a system is where I think things fall short. I mean, I would love just the paint to last as long as the asphalt. That's just like a basic. So if you take one thing, I need paint that lasts as long as the asphalt because it lasts maybe half as long. And then you can't, when you put the paint back on the asphalt that's 7 years old, it doesn't actually stick to the asphalt. So that it's a huge problem. So that's an actual problem that we have.
People would like you guys more if they knew that.
I know. They would hate us for 8 other reasons, but yeah. So like I think there does need to be more connections. Like what are the problems we have? I think another key failing is sometimes not truly understanding how technology fits within a system or within an ecosystem. And often there's hidden ways that the system needs to change that maybe the research says, little hand waving, that'll be done, but are really seismic shifts in how people actually act.
I think.
Yeah, we're gonna have 20 minutes for questions. So.
Oh, okay. I think from the viewpoint of private sector, money matters, right? And this requires a sustainable business model. So you can come up with a solution and provide it to a city, and it's the city adapts it. after the provider makes all the adjustment that will fit the local needs. And then the provider wants to sell this same solution to another city, and they would require another set of adjustments and so on. Now, this will not pay off the research and development efforts by the private provider. So you have to have a scale of the market, and you need some standardization so that with minimum alteration to fit local conditions, this protocol solution will work for a large number of cities. And the national government has a role to play to facilitate this process by way of adapting sort of standard protocol and spread it to local authorities. And one way of doing it is to start with a research and development project at the national level, funded by the national budget. And then after pilot testing, if it becomes feasible, then promotes it to local governments. In some cases, some cost sharing would work if it's in the national interest. But in the end, private sector, is not a charity. They have to make money doing something like that.
Okay, so one last question from my side before proceeding to a Q&A from the audience, and it's, you mentioned scale. Mm-hmm. And obviously that's something very important for researchers, since the need to scale these innovations sometimes may be the decision maker on whether this is an innovation that will become commercial or not. Mm-hmm. And so it's within a city, obviously this scale could be just as for individual, for a community, or at a city level. And but so what I mean, for cities, what is more strategic to support? What sort of a scale? Because in energy, I would say that, like the example, rooftop solar seems to be a great solution for having very resilient cities. At the same time, rooftop solars have the cost of rooftop solars is 6 times what it could be at the utility scale. So you have this trade-off of then what is the most cost-effective way that the city can, I mean, you want to support the innovation, but obviously what is the scale that may be preferred?
It depends on what kind of innovation we're talking about. If you're talking about a new wastewater treatment process, and utility has to take 1/20th of its tanks down to replace it in order to test it, that you're talking a multi-million-dollar study plus the operations and everything else, and no one has time and no one really does that. That's one of the barriers to the entree of innovation in big treatment processes. But if you're talking like pipes, we're very innovative because we have a lot of pipes, so we can test the robotics or the drones or other systems for leak detection or quality of the pipes. So it depends on what piece of the infrastructure you're talking about, and also the value of making the change. Mm-hmm. So the value for making a change wholesale on a wastewater treatment plant only comes when you're starting to talk about going to, as Josh pointed out, the water reuse. You're going to water reuse and you're starting to recirculate the water so that the urban water cycle doesn't start at the river, drinking water treatment, through the home, back to the wastewater plant and back into the river, but becomes a circular system where you keep recycling that water. When you start to need that, and we are many parts of the country and the world, that technology becomes more important and rises up to the top, and the innovation does happen.
Mm-hmm.
Yeah, I think, pilots are always, something that you can pilot is almost always easier, and then something that you can't pilot, there just has to be overwhelming evidence, that something is going to work. this isn't really a technological innovation, it's more of a policy innovation, but we're looking to redesign the bus network in Philadelphia. And it's something, because of a whole lot of reasons, we just have to do all at once in one day, right? So that's a really huge initiative that we've spent like 4 years building the case for, and several other cities have done it. Whereas like a data processing pilot, we can just try it, on a small scale, and it works well. Or a new way of a new street design or a new curb design. It's really easy to pilot those and get some context-specific evidence that they're working before deploying them more widely.
Yeah, I think I do agree with previous comments. It depends on sort of the nature of the innovation and its expected impact. But in Korea, we are now experimenting with this idea of low impact development, which is related to what you talked about in terms of minimizing the use of water and then encouraging reuse of water. But this is qualitatively a good idea. Whether it's a quantitatively good idea is questionable. But my point is that the solar panel at every rooftop, economically, not necessarily an economically good idea, but people feel good about doing this because they know they are serving the cause of some good cause, dealing with global challenge, right? So sometimes we encourage behavior on the basis of pure economics, but some other times we do, for some other reasons. I think it's a matter of choice.
Okay. All right, so let's turn to the audience if there are questions. Karen.
Yeah, hi. So I just want to ask a question. This morning, I'm going to ask this question of Christopher. So this morning, Ann shared that one of the goals for Philadelphia is to become 0% landfill. I'm just curious, like, what strategies are on the board, and why is Howard laughing?
I'm laughing because what a vision that is. Okay.
So I mean, did I hear that right? Like, we're trying to go to
zero waste. Yeah, a zero waste city. I think there's things we can do, and then I think there's things that that vision only really becomes a reality when the entire production sector takes responsibility for disposing of the products they produce. Things like small composting. I think that's probably one of the next. When I say next, probably 4 or 5 years to try to pilot and then roll that out a little more widely. And I think this is maybe more feasible than it was 10 years ago, perversely because of the change in the Chinese recycling markets. I don't know if you know this, but they stopped accepting really dirty recycling content, and they drastically changed the amount of impurities that could have in it. And so most of the recycling markets in the U.S. flipped from being a profit maker to being a loss maker. And in fact, we've been paying more to dispose of recycling than we've been paying to dispose of just regular trash, if that's crazy. I think part of it is not only can you now put your food waste in the compost, but now a lot of that paper that any paper that's soiled, like your pizza box, you can't recycle your pizza box in Philadelphia. Don't do it, because it's got grease on it and it just doesn't work. But if we can find a way to do composting, I don't think that gets us all the way to zero, but that gets us a good bit of the way there for wet and soiled paper products.
That's a global impact. I mean, the Chinese policy decision. But I don't know. Sometimes we set a goal high enough to impose pressure upon us. So if we aim very high, we could get closer to it. I don't believe that 0% landfill is feasible in the near future. But on the other hand, we have to be ambitious enough to make our best efforts to approach that goal.
Is there any estimate, like, if Philadelphia composts everything it possibly can? What fraction of that?
I don't know those numbers off the top of my head, but I can try to connect you with Nick Esposito. He's the leader of our Zero Waste and Litter cabinet, and he should be able to give you that data.
to just ask a follow-up question. So Philadelphia apparently did really well with the soda tax, but why not put some of the cost of using like the not renewable plastic bottles back to the manufacturers? Like, I guess the bigger picture question I'm asking is that the waste generated is by the manufacturers, and then Philly's paying to recycle it.
Yeah.
Can we put some of that back on them?
I think we should.
Reduce the cost?
I think there are some things that are solvable at the local level, and some things that are frankly not, solvable just having Philadelphia do that. Some things we're legally not permitted to do, and I'm not sure if we're legally permitted or not to put a fee. I think we probably could, but put it on maybe not the producer, but at least on the retail side we could do. But is the system benefited, or do people just drive 3 miles that way and then buy all of their plastic goods at a cheaper price? When you've got manufacturing on our scale, I think there's some of these issues we really need a national solution. So we'll see what happens next year.
I have a question regarding the local taxes. Do you have an idea of the proportion that is, for example, dedicated in the local taxes to transportation, infrastructure, and sustainability? I don't know how it works precisely, but...
Yeah, so the cities, for infrastructure, paving is the largest thing on the city's infrastructure budget, but that doesn't include the water department or the airport, which also have really some of the biggest capital expenditures. The city's overall budget is about $5 billion, and this isn't an exact number, but the streets department budget is somewhere around $100 million. So it is a relatively small portion. I think police and fire take up just by themselves about half of the overall expenditures of city government. Yeah,
Sorry, can you repeat the question?
Yes, do you support also all the train station fee?
Yeah, so I'll just add to that. There are state and federal funds we also get to support the infrastructure responsibilities that are in the city. For the transit that you're mentioning, trains and buses, that's the responsibility of a regional agency. The funding mix is really different for every single city in America. For our city, something like 60% of the funds for the transit agency, which is actually a 5-county, has a much larger geographic scope. About 60% is from the state, and then there's a local matching requirement. It's less than 10% comes from local sources.
I have a question there, and then here, Josh.
So it seems like from the various panel conversations that there's a lot of talk about innovative technologies and how we can implement them in the future. And right now we're trying to implement the current technologies, and there might be economic solutions. It seems like, especially with the very ambitious plan by the current Philly government to kind of have all these goals by 2050, which I think are great if we could get to them, it seems like more it's planning for the technology of the future, or implementing for the technology of the future. I guess, what kind of challenges are there when you're trying to balance, well, how do we incorporate policies that can be effective with the technology we have now, while also considering the technology we might have moving forward?
Yeah, maybe Howard could talk about the water perspective. I'll just talk about some of the transportation perspective. I think we're entirely focused on the technologies of now implementing. So, there's several reasons why, in terms of saving energy, we've primarily gone on a mode shift strategy of people getting walking, biking, and transit versus an electric car strategy. One is that the former hits multiple policy goals, not just energy reduction, but also congestion and equity. But I think another piece is that the technology, I just don't think is there for the electric car for an urban environment, especially one like Philadelphia, where nearly all of the parking is on street. And we tried people having personal electric chargers, and there was just a ton of work for it. Now, I'm hopeful that in the next 5 to 10 years, the technology will change, and the charging times for an electric car will go from several hours to something that's much closer to the amount of energy you're able to put in at a gasoline pump, so that something where you just stop in, wait a few minutes, and then leave to get your charge on. But we're not there yet. So for that reason, we're planning. We're not making a major push right now for EVs. Not that we're not doing anything, but our major push is on making transit better, making walking better, making bicycling better, because that's where we think the current technologies, like today and in the next 5 to 10 years, are pointing us.
Josh?
Yeah.
It was Josh, and then.
Yeah, I think the idea of public-private research partnerships could be enhanced. Perhaps I think what you mentioned of private sector coming with solutions for problems you're not actually concerned about. I've seen it was Mark Dowd from the DOT Smart City competition, who's now launching a civic innovation challenge. He's called it, for state-level smart cities alliances, reverse pitching. Mm-hmm. So the public sector is the lead in just identifying and defining the problems or the challenge statement that private sector research and others can experiment. And I'm wondering, I think economics certainly plays a role, but I think what was mentioned of, it's not always technical, the congestion, it's sometimes social, cultural, economic, and so I think of an example like Uber as an approach of, I've seen two different strategies. One is, let's fly as low under the radar for as long as possible until they can't stop us. There are enough people see this is a valued service. Or the trust, the relationships, or understanding and mapping out who might be that opposition to whatever you're trying to accomplish, and how do you bring them on board. And I think what you mentioned of the risk-averse civil servant, I'm wondering how do you make it a win for them? Because I think there's more loss than benefit, and I wonder if there's a way to rethink the incentive structure for people to, I think of Gandhi, be the change you wish to see, try it, test it, and just do it and get rewarded. Whereas right now it seems like if you try anything different, you're punished. It's more work, or there's more risk. And so I think that window of crisis, or crisis as a window of opportunity, seems that place in which maybe there's a new incentive structure. I'd be curious to hear any thoughts there.
To me, change management, which is what you're really talking about, is a very personal thing. And it's one person at a time. And whether you're talking utility, government, private sector, everybody loves change as long as nothing looks any different after it happens. But it is difficult, and it is, and people do get angry. They have a whole series of reactions to change, and it takes perseverance, and it takes a good vision and some good data behind it.
Yeah, it's difficult to change the culture within a short period of time, but it is possible to make good examples, to identify some good examples. And my own experience is that there are many qualified mid-level civil servants who are willing to experiment with innovative ideas and policy solutions. And depending on who they work for, who their immediate boss is, it could go further up, or just case closed. So I think it's important to demonstrate that these more sort of brave people are rewarded in the system, and there are some cases like that. And then reputation works, because in my own ministry, I could remember some names who always try to come up with new solutions, even if they do not go through all the way. So, and people are aware of that. So I think it's slowly changed the culture, and I think it's also it also depends on where you stand in your career. So if you have a longer term prospect in in your profession, you want to do more, more experimental approach.
I'll just say that we have we've set up a reverse pitch process in the city of Philadelphia. It's been difficult because we'd like to turn that reverse pitch right into a contract, and it just didn't fit so all the contracting rules had to be changed, but we're calling it pitch and pilot. So we come up with a problem statement, they pitch us, and we're able to move right into a small contract for some of the solutions, and I think we've made our first announcement. I can't remember the specifics, but it's in the zero waste arena.
We have time for 2 more questions.
I just want to thank the moderators and the panelists. That was very interesting. There are a couple insights, materials insights that I noticed, and I don't want to put anyone on the spot, but I found that paint that lasts as long as the asphalt. That's like a specific material insight, and I was wondering if any of the other panelists or moderators have things in a similar vein.
I'll start. I have one more. When I was talking to the folks back at the lab, so to speak. So when you flush the toilet, a lot of energy goes down the drain. So it's both chemical energy and thermal energy goes down the drain. So there's been attempts at there's heat exchangers. We had a small scale one installed at the water department, but one of the issues is that the heat exchanger pipes get covered in a biofilm. Some gunk gets on the inside of the pipes and reduces the effectiveness of that heat exchanger, and then it has to be washed out, etc. So improved coatings for the inside of pipes that could be used for sewage heat exchangers that didn't grow biofilm. And maybe you already have that, and we just don't know it, which is part of the innovation cycle. But that would be a specific materials-related request.
I second that one. That really is a big problem for us. There's so much potential for thermal heat in our sewer systems run through our cities. Plus, there's enough thermal heat at our wastewater plant to provide heating and cooling for the entire airport. But it's just a question of being able to capture that and send it back. And a lot of that has to do with biofouling is probably the biggest issue we have with that. Another area also in pipes is there are a lot of pipe breaks in Philadelphia, and boy, would you love to have a and somebody said this already today, self-healing pipes. I have no idea what that means, but if you can put pipes in the ground that have some material that as erosion, corrosion, or breakage starts to occur, can provide self-healing, that would be really fantastic. Big breakthrough.
I'll pass.
I would say for manufacturing, obviously this is a sector that is still, for some industries, is very energy intense. And I think material science researchers working with tribologists should look more on cement manufacturing to make it way more efficient, because some of this machinery that they use are very old and not maintained, and it's a very intense, energy intense process, but the fact that the machines themselves are very energy inefficient, I think there is a lot of room for improvement in that sector. So I think there is one more. Do we have time? Ross, yeah? One more question.
So I don't have a question, I have a proposal. And based on the...
This is for the whole audience, yeah?
Oh, definitely. Yeah. And it had me thinking about my experience as an undergraduate in economics and as a graduate student in city planning, and then as a professional in several sectors. And I've heard on a half dozen occasions, points that suggest a course where you'd have, let's say, a third of the course would be practitioners, and a third of the course would be focused on some material science innovation, or more broadly, some technological innovation, and another third of the course where you'd actually try to apply it For instance, aligning the longevity of asphalt and paint and what that would look like, trying to push it through city council and having the paint industry push back through lobbying to not extend the life so that they could sell more paint, you know? So this course, it would be something like how to convert material science innovation into public policy.
Okay.
I've just created a job, I hope, for somebody.
Great. Well, I will thank everyone for a great audience, very wonderful questions, and an applause for our panelists.
Okay, so this is my second time joining to the REACT Symposium, and it's a really great honor to me to give the closing remarks on behalf of the Korean delegate. And first of all, I'd like to thank and actually we have a very great discussions on the very important agendas on the sustainabilities of the new the urban challenges. And first of all, I'd like to thank all the speaker and panelists and all the participants who made today's event very successful. And recently we have experienced very unusual the warm winter weather here in Philadelphia, and probably which might be influenced by the global warming problem. And this is another good reason to discuss about the issues about the sustainability of the urban habitat against the future challenges. And I came from Seoul, and I'm not sure how many people have visited Seoul before, but if you have not visited there, some of you concerned that the Seoul is in reach of the possible threat of the Kim Jong-un of North Korea, but basically the Seoul is very secure and highly innovative, and also the ICT technology leading city of mega city of the 10 million people. And as we already have learned today, the managing the issues of the urban challenges need to be evaluated and managed in a very different way according to the sizes and the capacity of the city. So, for example, in Seoul, we have the multiple downtown along with the city center, and which are all interconnected with countless numbers of the transport and distributions of the people, goods, and potential the possible the resources. So, which means, and also, as Professor Kim also mentions that the highly populated, densely populated district are all faces without any physical or natural border, which means that even if we are placing a very slight changes in very specific location, this is immediately propagated to the whole the surrounding area. So, for example, so when we dealing with the issues of the air control or the water quality control, that we are always facing the issues of how these kinds of influences can be managed. And so it should be managed from a very fundamental levels of the scientific level, but expanding into the considerations of the societal impact as well. So based on this, understand the issues of the urban challenges is across the multiple, the city scale will be quite relevant for under this situation. And for this end, and as far as I know, you guys have managed a 5-year NSF, the International Partnership Program, in between the UPenn and the Grenoble, the giant Grenoble, and also the very fortunately, the last year, the SKKU South Korea and Grenoble, the giant people. So we made a very successful the local, the international, the networking program in between the Korea and the Francis with a support from the government. So our next goal is to expand and merge the partnership program in between the U.S. and France and Korea over a intercontinental scale to deal with these important issues about the urban challenge issues, and where we can do a very good and successful discussion and proposing a solutions for including and participations of the lots of experts across the all technological area, including a participations from the policy experts. So thank you again, and I hope the wonderful relationship can be continued for the next year with the great the partnership program. Thank you.
Thank you, Phil. So on the behalf of the French delegation, I will also thank Russ, Christine, and the whole REAC family. I'm including students, faculty members, and everyone who's making this project so interesting. So it's my 5th time here in Philadelphia, so it's my second home, you know. It's a great pleasure to be there every year, and your problems are becoming my problems. I hope we will bring common solutions. And of course now it's not only in between Grenoble and Philadelphia, but also we are extended to Seoul, Suwon, that we started to interact with. And I think that's very important what I'm pretty sure you have already a feeling that what you've said today will impact our whole life. Because now, you know, we would like to keep contact with you. We are discussing in between researchers. We like this TRL scale very much. We like to climb over it. And so now we have a lot of technical issues, how to implement innovation. And we would like to keep this link that we established today so that, you know, we can come on together in a few years and saying, okay, we haven't solved all the problems, but at least we've identified some of them in a clever way. And I think that's the great message we get from this program. It takes time to work together. We're very different, but we're all human, so we have a very common interest to develop things. We're just doing it in a very different way. And I think that's the interest of this NSF type of program, international collaboration. We're identifying the problem very accurately, and then we try to find a solution best fitting our local things. And I think I was saying that, you know, maybe you have no interest or knowing what we will be doing in the next days, but in fact what you have said today will fuel exactly what we will do during the next week. We will start to discuss, and taking your message from today will help us to shape our new program. So the idea is really to make this, you know, this fully added value chain from basic research, technology, till society and people. Because, you know, whatever researchers are doing in their world, you know, we can speak maybe many hours of what I'm doing. It's not interesting. It's maybe not just interesting me. But then what is interesting for all of us is that we can maybe impact the life of everyone here if we're working together. So on this closing message, I would thank again all the people who have made this day possible, and all the panelists and the speakers we have today for this wonderful opportunity to exchange and have new ideas. Thank you.
My job is just to close things off for today before we have a reception downstairs. Let me just thank all the speakers and all the participants today again. Can we give them a round of applause? Many of them have gotten out of their comfort zone and really stretched their knowledge on the technology side. I would really appreciate that. It's more than I could say I would do on the policy side of things that you're experts in. So that's number one. I'd like to thank the funding agencies again. This includes Penn Global, School of Engineering, Penn Arts and Sciences, National Science Foundation, A&R, and our long-standing industrial sponsor, Salve. I also want to thank our partners from Penn, the Climate Center for Energy Policy, the Water Center, the Institute for Urban Research, and we hope that today's symposium is going to nucleate new collaborations across all of these groups. Patrice said a few of the things I was going to say, but REACT is a starting point. This is our 5th year of having this retreat. And after every retreat, we nucleated new interactions. Last year with Korea, this will nucleate further interactions. It's just what we do. It's in our DNA. Finally, and most importantly, I want to thank Dr. Kristen Field. Kristen raised the funding for this symposium. She planned the symposium. She organized the symposium. She communicated with everyone in this room. We couldn't have this symposium and tomorrow's research retreat without the due diligence of Kristen. So I think we should give her a great round of applause. And finally, thank you for...
Absolutely. It's the audience and the speakers and the audience that could not have happened. And all the people in the room are the ones who are going to take all these messages forward. So thank you, everybody. And this is actually just one-third of the way through the event, I think, or depending on how we count, 2/3. Anyway, thank you for joining us. The room is packed. It's really nice to see everybody here. And I hope, I feel like we've gotten so many different ideas from this, and how fun to be in a room with all these different disciplines and ideas and people with different backgrounds. So let's go forward with it.
Right. So, thank you. And finally, thank you for participating. I hope you gained some wisdom that brings you closer to your professional and maybe personal goals. So as a reward for sticking it out, there's a public reception downstairs on the first floor of St. Hopefully you can chat among yourselves, bring some index cards. Please don't forget to put the index cards into the basket at the end. And please talk to our visitors and introduce yourselves, because they're interested in hearing your thoughts. And Zachary, thank you very much for those questions. The last couple of questions actually were brilliant. So Zachary's one of our undergraduates, so thanks.